Hey there! Let's talk about vector and matrix quantities. First, let's start off with vectors. Vectors are arrows, lines, in graphs, normally on an x and y plane, and they have a direction and a magnitude. And right here, this would be the magnitude, pretty much how long it is. And the direction is the arrow, so that'd be direction. It's all determined based on where it is on a graph. So let's say we have a line here, and the line reaches until 3, 4. We can calculate the length of the line, the magnitude, by figuring out its x and its y. So this would be the x, and up here would be y. And you can see it forms a triangle. So we know x would be until 3, so x equals 3, and y equals 4. And we would use the Pythagorean theorem to figure out what is the hypotenuse, which we'll call r. So 3 squared plus 4 squared equals 5 squared, the very famous 3, 4, 5 triangle. So r would equals 5. And that's the length of our vector there, and we can use a lot of other applications to it, such as the following. First off, a vector has a tail, which we'll call A, and the head, let's call it B. The tail and head, and we would always write this out as A, B, with an arrow, so it's like an array. And we can add vectors together. Let's say the length of this vector would be, let's say, 8 and 10. And we're trying to add it with another vector, which is 4 and 2. If you add them together, we have to add each one to each one. So these two would add together, and these two would add together, and we would get 12, 12. We can also subtract vectors, which would be the same thing. And let's go to multiplying vectors. So we would multiply vectors by a real number, which is called a scalar in this case. So if we would want to multiply a vector by a scalar, what we would do is kind of write it like this. So let's say we have this, we'll call it A, and we're trying to multiply it by an additional vector. So if we would want to multiply this edge, let's say the edge is 3. So we would write it as, if this was 4, 2, we would say 3 times 4, 2, which is, you multiply each one like the distributive property, and we would get 12, 6. And we can also multiply and graph it, and there's a million applications, but this is just the basics of vector quantities. And let's now move on to matrix quantities. Matrices are pretty similar to actual vectors, and you can actually apply them together. Let's talk about the basics here. So a matrix looks kind of like a box, really. A box full of numbers. So let's say we have 5, 13, 6, 3, 9, and 2 in our box. And this box is an array. And if you have ever coded, that's what you would use a lot of times, an array of numbers. And this has 2 rows, which are the sideways ones, rows, and 3 columns, which are the up ones, columns. And some basic things you can do is you can add them together with another array. So let's say we have another one. Let's just make it like 3, 6, 4, 5, 9, 12, 9, and if we add them together, they each have a certain place in their array, so we have to correspond each position with another one with a similar position. So this would be 1, 2, 3, and 1, 2, 3. And you can see where this is going, the corresponding numbers. So let's just say that as an example. That's not the official terms. If we wanted to add them together, we would get 5 plus 3. Spin our new array. We get 8, 19, 10, 8, 21, and 11. What else can we do? Well, we can subtract as well. So let's do that. Let's subtract. And if we subtracted, we would get 2, 7, 2, negative 2, if we're doing this subtracted by this, and negative 3, negative 7. What else can we do? Well, we have addition, subtraction. Next is multiplication. Here's where it gets a little harder. We can't multiply two arrays together. Well, we could, but let's say we multiplied a matrix by a number, which, remember, before we called it a scalar. So let's multiply this one by 2. So it would make each number double. So this would be 6. Next one would be 12, 8, 10, 24, and 18. But if we wanted to multiply two arrays together, we'd have to do the same thing. We would do 5 times 3, 15, 98, 24, 15, 108, and 18. Those are all the really basic functions. And if we wanted to apply this, normally we would multiply two data tables together. And these data tables, when you combine them, they make longer strings or other applications. So, thank you for watching this video. This has been Vector and Matrix Quantities provided to you by SATFreePractice.com.